All right, so here we're going to do the 2020 AMC 10B problem number 22. It asks, what is the remainder when this expression is divided by that one? Well, there's not a lot of words, it's not a big problem. It's just something about remainder, so we kind of don't know maybe how to begin. Let's just write, we're dividing, so let's write it as a fraction, right? Let's do 2 to the 202 plus 202 divided by 2 to the 101 plus 2 to the 51 plus 1. Okay, so we look for things that might be connected, right? So how does this relate to this? Is there some way? We're basically looking to manipulate the given information in some way that gives us something beneficial. So let's kind of do that here. We can see that 202 is twice 101. Maybe there's a way to capitalize on that. So you might not see it in your mind. Go ahead and just write this in a different way and see what it generates. So we can say that 2 to the 202 plus 202 is actually 2 to the 101 squared plus 202. Okay, so we got something squared plus this, and that something that's squared matches this one. Maybe we don't know where to go with that. And now, from this point, it's going to kind of depend on your experience and how well you take notes and pay attention to little details that might seem not that important. For example, I talk a lot about Volume 1, the book from AOPS, and how impactful it is on the test. One of the things they mention in here, it's mentioned other places, you don't have to get it from Volume 1, but if you look right here, it is the sum of the squares, right? I'll hold it here for you to see it. The sum of the squares. It's part of chapter 7 in special factorizations. And so that thought, right, if you're aware of that concept, you've seen it before, because in school we usually just say you can't factor sum of squares, and that's true, you can't really, but you can still manipulate it. So it's a manipulation of it. And basically when you're adding two squares, you can make it the sum of the bases squared minus 2ab. And it's really easy to prove it. All you have to do is add 2ab and subtract 2ab. Right? This will become that, and then you have the minus 2ab. Okay, so that's great. Let's just leave it up there, I guess. How is that going to help us here? We have a plus, we don't have a square, but does 202, is it like locked down? You can't separate it or anything? No, you can. And maybe you should try to pick out a perfect square to go here. The question would be which one. Might be a little bit of luck, could be a little intuition. I would probably start with 1. One of the reasons being this 1 right here. Maybe there's something we'll get out of it if we make it like that 1. If not, you might try it because it's the first integer perfect square. So if we did that, if we made this 2 to the 101 plus 1 squared, right? I would need to make this 2 to the 101 squared plus 1 and then plus 201, right? So this part would factor, and we've got this 201, which we don't know what we're going to do with. We do see that number's up here. Maybe that'll come into play later. We don't know. Let's just take this and try to do this with it, right? So that it became 1 squared. And I want it to look like that expression, which means I need to subtract 2ab. So I would get 2 to the 101 plus 1. That's the a plus b squared. And then I have to subtract 2 times the a, which is the 101, times the b, which is 1. You don't have to write this, but might as well to see consistency. And then plus 201, the same 201 that was here. Okay, so we did that, and it changed the appearance, but does it help? We don't know yet. Let's kind of look around and look for some other observations. Again, this and this have the same base. Maybe we should combine them. Let's do that. 2 to the 101 plus 1 squared minus 2 to the 102 plus 201. Okay. Hey, that's a perfect square, and this is a base to an even power, which means it's a perfect square. And last time I checked, that's a minus sign, which means we have the difference of squares. And sometimes we'll ask ourselves questions like, yeah, but will it help? don't ask that question. I mean, okay, it's okay to ask it. But if you don't know where else to go in a problem, just explore. Take that path and see what's on it. You might not know till you've got it written, right? So let's write it and see what we get. We get 2 to the 101 plus 1. The square root of anything, you just cut the power in half, right? So it would be plus 2 to the 51, and then times 2 to the 101 plus 1. Again, that's the a from a squared. And then it's going to be, it was plus here, it'll be minus 2 to the 51. And then we still have that plus 201 over here. Oh, wait a minute. That's this. Well, that means this would cancel into that. Don't forget, this whole expression is like this. 2 to the 101 plus 2 to the 51 plus 1. It's not just this expression, but also the 201 is on that. We can see that we can cancel it here. Basically, we could say that we have x plus y over, I don't know, z. And in that situation, there's no problem to change it to x over z plus y over z. And if that z cancels with the x to leave, a remainder here, what would that make the y? Well, that's the remainder, right? It's just the remainder algorithm. Some entity, usually a function or something, is equal to the quotient plus the remainder over the divisor. And we showed that when I divide this by this, the result was the quotient, which would be this expression right here, and then plus the remainder over the divisor, right? So it's actually the function over the divisor equals this. And so that's what we have. So the 201, it's the answer, right? And so that's how you kind of explore these kinds of questions. You don't always know where you're going or what you're doing. It's a process of discovery with a little bit of luck, perhaps. And depending on your experience, how well you took notes from various resources, be it AOPS or handouts they make or Discord communities, you need to take notes on that, store the formulas, and be able to review them right before you take the test to increase the chance you might think of the sum of squares factorization or the way of writing it. It won't always help, but in this case it did. I want to look at one more way. I'm going to pause the video, erase this part, and look at a second method. We'll be right back. Okay, so this is the second method now that we're going to do. And this one, I pulled it off the AOPS community solutions. I thought it was cool and I wanted to share it with you. This is not my original solution, but it's good. It's competent. It gets the job done, which is what the goal is. Get the answer, right? So I want to look at it real quick. Sometimes when you look at something, don't always see its given appearance. In fact, most of the time, you should try to mentally manipulate this and think about it in a different way. Think a little more abstractly. We can do a variable substitution, right? So when we look here, this is really close to a multiple of 50. So's this and so's this. That might give us the idea that we could say let x, like just a variable, right? And x is the most common variable, so let's do that. So what would this be then? It would be 2 times, 2 squared times 2 to the 200 plus 202 over 2 times 2 to the 100 plus 2 times 2 to the 50 plus 1. In fact, if you wrote it like this first, there's probably an increased chance that you could think, hey, why don't I just replace that with a variable? Well, let's see what it does for us. It's going to give us 4x to the 4th, because 2 to the 200 is 2 to the 50th to the 4th power, plus 202 divided by, we've got 2x squared plus 2x plus 1. And we're asked to find the remainder of this? That's a pre-calc problem, maybe algebra 2 for some honors algebra 2 courses. It's just long division. If you told me at the start of the test that I could get question 22 right by a simple manipulation that gives me long division, algebra 2, kids that don't do competition math can get this correct. But it's the kids that do the competition math that can think about this conversion. That's the difference, and that's what you have to train yourself to do, is don't just see what meets the eye, see how it looks different. Let's go ahead and do the long division real quick. So it would be 2x squared plus 2x plus 1. And I like to put 0 placeholders in. So plus 0x cubed plus 0x squared plus 0x plus 202. Okay, so it's 2x squared times what equals this? That's 2x squared. You will multiply out to get 4x to the fourth. You're back distributing. This is going to be plus 4x cubed and then plus 2x squared. Okay, then my method for long division is I don't subtract. I change the signs and add. That's the same thing, but subtraction creates more mistakes than addition does, from my experience. So I draw a line and I change these signs to negative and you add down. You will get negative 4x cubed minus 2x squared. If you don't know long division, I'm sure Khan Academy can remedy that. They have a lot of videos or other YouTubes. Okay, so then 2x squared, you're basically asking this times what is this? And it's going to be negative 2x. So we put negative 2x and we multiply to get negative 4x cubed. Again, you're back distributing. Minus 4x squared minus 2x. Draw a line, change all the signs. Add down. The first one will always cancel. If it doesn't, you're a bonehead. Fix it. Right? And you're not a bonehead, but people make mistakes, right? It should cancel. Think about what will make it cancel after you change the signs. So then negative 2 plus 4 is 2x squared, and then plus 2x, and then we drop the 202. Okay, last up, this times 1 is this, so we put plus 1, back distribute, 2x squared plus 2x plus 1, draw the line, change these signs, add down, everything's going to cancel, except for your remainder. Again, having a new way to look at something makes the problem trivial. See you guys in the next video.